All right, let's go ahead and get started. I do want to welcome you to the second installment of limiting reactants and percent yield. Let's get started with number three. Number three says identify the limiting and excess reagents when 25 liters of nitrogen react with 25 liters of hydrogen at STP. Let's define just a couple of things here. First of all, reagents and reactants are the same thing. And the second thing is STP, standard temperature and pressure. Remember that means you're at 0 degrees Celsius and 1 atmosphere of pressure, but most importantly, that means that for any gas at STP, you're going to have the volume 22.4 liters. That's going to be very critical in helping to solve these problems. So let's start with balancing the reaction. 1 mole of nitrogen gas reacts with 3 moles of hydrogen gas to produce 2 moles of ammonia. That's a 1 to 3 to 2 mole to mole to mole relationship. So let's start with the nitrogen. So they're telling me that I'm starting with 25 liters of nitrogen and 25 liters of hydrogen. And my strategy was to take each of these and determine the amount of product for each one of these individually. So remember that what I'm going to do is I'm going to essentially solve the problem twice. So let's start with the nitrogen first. We have 25 liters of nitrogen. I want to convert that to moles immediately. I know that I'm at STP, so I'm going to use 22.4 liters per mole to convert liters into moles. That will allow me to cancel those two units. I'm now left with moles of nitrogen gas. I need to use a mole-to-mole bridge to get to the right unit. So we know that 1 mole of nitrogen gas will produce 2 moles of ammonia. It's a 1 to 2 mole-to-mole ratio. Or 2 to 1, I should say. 2 moles of ammonia are produced from 1 mole of nitrogen gas. These two units are going to cancel away. I'm left with moles of ammonia. Now let's just get to liters because I'm being asked for the liters of ammonia as my product. That's the unit that I need. So we're going to do the same transformation that we did before. We're still at STP. Remember, the entire vessel, the entire reaction apparatus is at STP. So all gases are at STP. That means that all gases have the volume 22.4 liters. That allows me to cancel this unit with this unit, and I'm left with 22.4 liters of ammonia on top. When I multiply across the top, divide by what's on bottom, of course I get 50 milliliters. Remember that this 22.4, and that 22.4, we're just going to cancel away anyway. 25 times 2, 50 liters. So that's one of my products. Okay, so I have to compare this number, however, to what happens if I start with 25 liters of hydrogen. So I'm going to start all over. So we have 25 liters of hydrogen gas this time. I'll do the mole conversion, 22.4 liters per mole, because hydrogen is a gas, right? It is a gas, and therefore it has that volume at STP. So 1 mole of H2 then is going to undergo this transformation. What we're going to do is we're going to compare ammonia to H2, in other words, a mole-to-mole bridge. 3 moles of hydrogen gas produce 2 moles of ammonia. Again, 2 moles of ammonia produced by 3 moles of hydrogen gas, 2 to 3 mole-to-mole relationship. I'll cancel that unit with that unit. I'm left with moles of ammonia. Only one step left. Again, we are at standard temperature and pressure. So it's simply a matter of converting to liters, 22.4 liters per mole. This unit and this unit are going to cancel away, and I'm going to be left with 17 liters of ammonia when I multiply across the top and divide by what's on bottom, 17 liters of ammonia. So now I'm left with the task of comparing. We've got 50 liters of ammonia when we start with 25 liters of nitrogen gas and have an unlimited amount of hydrogen. And we've got only 17 liters when we start with hydrogen gas and have an unlimited amount of nitrogen. So obviously the lesser of these two numbers is the 17 liters. And so my product, the amount of product that I will have is 17 liters. If I want to know the limiting reactant, I'll go back from here, that 17 liters of ammonia, the lesser of these two. I'm going to go back to hydrogen. So the limiting reactant is hydrogen gas. The other one, the nitrogen gas, is the excess reagent, and I'll label that ER. So we've got limiting reactant H2, excess reagent, N2, product, 17 liters. and I'm done with number 3. Let's move on to the next one. Okay, number 4 says this. It says a 50 milliliters of a 2.00 molar, that's moles per liter, H2SO4 solution reacts with 75 milliliters of a 2.00 molar sodium hydroxide solution. Identify the limiting and excess reactants. And then I'm asked how many grams of sodium sulfate will be formed. All right, so here we go. We're going to start with a balanced reaction. It's a 1 to 2 to 1 to 2 mole to mole to mole to mole relationship. Now what I'm going to do is, in my head, I'm going to start with the H2SO4, and in my head, I'm going to convert milliliters to liters by simply moving the decimal place over 1, 2, 3 places to the left. When I do that, I get 0.050 liters of H2SO4. I'll put that over 1, and I'm going to multiply that by the molarity. So volume times molarity gives me moles. So now that 2.00 capital M is converted into moles per liter. That's what that capital M means. Molarity means moles per liter. So now what I'm going to do is cancel this unit with this unit, leaving me with moles of H2SO4. So remember, I've told you, get to moles of reactant as soon as possible by whatever means necessary. So one way to do that is by multiplying volume by molarity, and I've done that. Now what we're going to do is a mole-to-mole bridge. We're going to bridge over to product. Product, of course, that I'm interested in is Na2SO4, sodium sulfate. And that's a 1 to 1 mole to mole relationship. 1 mole of H2SO4 produces 1 mole of Na2SO4. A 1 to 1 mole to mole relationship. This unit and this unit are going to cancel away, leaving me with 1 mole of sodium sulfate, Na2SO4. Now what I'm going to do is get to grams, right? Because it's asking me about grams of Na2SO4. So I'm going to get to grams. How do I do that? Add up sodium twice plus sulfur plus oxygen 4 times. When you do that, and check me on this, you get 142.05 grams per mole. This unit and this unit are going to cancel away, and I'm left with grams per mole, or grams of sodium sulfate. So I'm going to multiply across the top, divide by what I've got on the bottom, and I get this number, 14.2 grams of sodium sulfate. Now I'm going to start all over again, this time with the other reactant. In this case, it's the 75 milliliters of the 2 molar sodium hydroxide solution. I'm going to start by converting the milliliters to liters. I'll do it in my head just by moving the decimal place over 3 places to the left. So here we go, 0.075 liters of sodium hydroxide. Then what I'm going to do is multiply that by its molarity, which is also 2.00 molar. So when I do that, liters and liters is going to cancel away, and I'm left with moles of sodium hydroxide, right? There should be an oxygen right there, okay? Sodium hydroxide. So now what I'm going to do is I'm going to do a mole-to-mole bridge. So my mole-to-mole bridge is a 1 to 2 relationship. 2 moles of sodium sulfate produced by 2 moles, 1 to 2. 1 mole of sodium sulfate produced by 2 moles of sodium hydroxide. It's a 2 to 1 ratio, right? Or I should say 1 to 2. 1 mole of sodium sulfate produced by 2 moles of sodium hydroxide. And that gives me the mole-to-mole bridge that allows me to cancel this with this. I'm left with moles of sodium sulfate. I want to convert that to grams. Again, 142.05 grams per mole. That allows me to cancel that with that, and I'm left with 142. When I multiply across the top and divide by the bottom, 10.7 grams of sodium sulfate. Now I'll do my comparison. 14.2 compared to 10.7. This is the smaller one, so 10.7 grams of sodium sulfate is the amount of product. 10.7 grams of sodium sulfate is the amount of product. And to find out the limiting reactant, I'm going to go back from here. So I'll go all the way back to sodium hydroxide. That's my limiting reactant. Sodium hydroxide is my limiting reactant. The other one, H2SO4, is my excess reactant, and I'm finished with number 4. Let's go to number 5. Number 5 says, a chemist burns 16 grams of aluminum and 50 liters of oxygen to produce aluminum oxide, and we're at STP. So remember that STP means 0 degrees Celsius, 1 atmosphere of pressure, but most importantly, all gases have the volume 22.4 liters. It says first write a balanced equation, then identify the limiting and excess reactants and calculate the grams of aluminum oxide formed. So I've written a balanced reaction. Aluminum, it's not diatomic, it's not one of the Brinkelhoff elements, but oxygen is. So plus oxygen yields aluminum oxide. Now, that's a 4 to 3 to 2 mole to mole to mole relationship. So practice that, convince yourself of that. So now that we've got the balanced reaction, we're going to start with the first reactant, which is the 16 grams of aluminum. So I'll start there, 16 grams of aluminum, and just goes through the same routine, times 1 mole of aluminum per 26.98 grams of aluminum. Just got that right off the periodic table. Those two units are going to cancel, leaving me with moles of aluminum. Now what I'm going to do is I'm going to do a mole-to-mole bridge. 2 moles of aluminum oxide form from 4 moles of aluminum. 2 moles of aluminum oxide form from 4 moles of aluminum. So that is a 2 to 4 mole-to-mole relationship. This unit and this unit are going to cancel away, leaving me with moles of aluminum oxide. One final step, convert to grams. And so I'm going to add up 2 aluminums and 3 oxygens. When I do that, I get 101.96 grams per mole, if you'll check me on that. So moles and moles are going to cancel, moles of aluminum oxide are going to cancel away, and I'm left with grams of aluminum oxide. Multiply across the top, divide by what's on bottom, and here's the number I get. 30.2 grams of aluminum oxide. Now let's do it again, this time using the other reactant. We've got 50 liters of oxygen. So I'll start with 50 liters of oxygen over 1 and then get to moles as soon as possible. I know I'm at STP, so I can use this relationship. 22.4 liters of oxygen per mole of oxygen. Let's make that an O right there. Per mole of oxygen. So this and this are going to cancel away, and I'm left with moles of oxygen gas. Now what I'm going to do is a mole-to-mole bridge. 2 moles of aluminum oxide produced from 3 moles of oxygen. So 3 moles of oxygen producing 2 moles of aluminum oxide. So it's a 2 to 3 ratio. This unit and this unit are going to cancel away, and I'm left with moles of aluminum oxide, Al2O3. Now what I'm going to do is convert that to grams. Moles of aluminum oxide, moles of aluminum oxide. I'm left with grams of aluminum oxide. That's 101.96 per mole. So I'm left with moles of grams of aluminum oxide. When I multiply across the top and divide by what's on bottom, what I find is 152 grams of aluminum oxide. Now it's time for me to do my comparison. We're going to compare 30.2 grams of aluminum oxide to 152 grams of aluminum oxide. It's obvious that the 30.2 is less than the 152, so that's the amount of product I'm going to get. So now what I'm going to do is I'm going to look to see what the limiting reactant is. I'm going to go back from there, and I determine that aluminum is the limiting reactant. So the other one must be the excess reactant. So once again, aluminum is the limiting reactant, oxygen is the excess reactant, and the product is 30.2 grams of aluminum oxide. I'll see you on the next one. Thanks. Bye-bye.